So it's going to do 3 times factorial of 3 minus 1. So 3 minus 1 is 2. So it's going to call, again, factorial with 2. It's going to try to match with the first one. 2 is not 1, not a match. It's going to look for the second one. Again, it's going to replace it until 2 minus 1 is 1. Factorial 1 is called, and it's going to match the first one and then return 1. And that's what we call the terminating scenario. So every recursion, every example of recursion has these 2 scenarios. The terminating scenario, when the recursion ends, and the recursive case, which is the function that keeps calling itself. So factorial 3 is going to return 6. Factorial 4 is going to return 24. This is the simplest version of factorial in Elixir. What's up?
So the matching is not because it's an order, but because one is more specific. Like like n is free bound.
Yeah, you go from more specific to more generic, right? If you go otherwise, first of all, the compiler is actually going to help you out. If you try to compile an Elixir program, it's going to call you out saying, hey, you might want to reorder these functions because the function at the top is going to catch all and the function at the bottom is never going to be reached, right? So yeah, the order here absolutely matters. Yeah. All right, so this is like me trying to learn functional programming in college with like Lisp and Scheme, learning factorial. I'm like, all right, cool, factorial. Like, how do I use this on like a web app that a friend of mine wants to build, right? Like, there was like this huge gap between like what a website or a book is trying to teach me in academia and what the real world is actually requiring me to do. So I'm going to show you an example of like real world scenario where we can use recursion, pattern matching, and pure functions. So I'm going to use Orlando City as an example. Huge fan, haven't been in a game in a long time. So suppose that we want to build a simple program that reads from an API and lists the players of the Orlando City team, right? So here at the top would be an example. So suppose there is an API that provides us with like text format, JSON. We want to be able to fetch that API, build a list, and then return the list of players for the Orlando City team. What we also want to be able to do is read that same data and spit out just the goalie, right? So we want 2 things. We want to list out all the players from the team, and we also want to be able to list out only the goalie. Cool, let's see how we can do that. So we'll start off with the soccer team module and 2 functions, list all and get goalie. So the first one, as the name suggests, is going to list all the players. The second, all the players, a list. And then the second one is going to just get the goalie. So we're going to call them like that. List all, get goalie. So let's look at the first one, list all. So here's one potential implementation. So here at the top, we're going to use a common library for HTTP called HTTP Poison. So kind of like bear with me about this syntax. I'm not going to go over what it does and what use means. You can kind of like figure it out. So we have a URL, right? So this URL is the endpoint that returns the list of players, right? Then we use the get URL method. That's part of the HTTP library. We make that HTTP request to the API. We get back JSON as string. Then we're going to pipe that to the parse function that we have at the bottom, right? Now, we're not going to go over all the edge cases. If the call goes wrong, if the server's down, if internet's down, let's just follow the happy path, right? So the happy path for calling this endpoint would be a 200 response back from the server with the response body, right? So that's exactly what we're going to match here at the bottom. So we're going to match with a map that has the key status code set to 200, and then whatever body comes with it, we're going to assign it to a variable called JSON response. Now, how many of you here have written code that does something like this, that fetches data from an API, reads data? All right, cool. So I just want to give you a couple seconds to try to picture what that code would look like in any other language that doesn't have pattern matching, right? You probably need to write at least 2 or 3 lines of code in order to check that the status was 200, to read from the body, to assign it to a variable, and then here we just do it straight on the function signature. So that's pretty dope.
Why the map here and not matching against 200 comma JSON response?
Because that's the format that the library that we're using, HTTP Poison, returns, right? So when we call the get URL, it returns a map. So we have to use that same representation, right? A map with a key, with 2 keys, right? Status and then body, right? In order to match.
Versus if it returned a tuple.
Correct.
Okay.
Correct. So yeah, like the difference is literally between a map and a tuple, like as far as representation, is the percent sign, right? Yeah.
That's what I'm thinking.
Yeah. So technically, this is a keyword. Well, let's not get into that.
I'm sorry.
What's up?
What is the difference between def and def p?
I'm sorry.
What is the difference between def and def p?
Private. Yeah. So def you can call like we are soccer team.list all from the outside of the module. But if you try calling soccer team.parse from outside of the module, that would error out. So it's a private method. Right, cool. So we matched on the happy path, right? We matched on the 200 response. We assigned the content of the response, the variable JSON response, which at this point is still a string, right? We want to convert that to an Elixir data structure. So we're going to use another library called Poison and call the function parse, giving it the JSON as string, and then what we get back is a tuple, right? And then again, we're following the happy path. A couple of things could go wrong here. We could read the data in a format that the library doesn't understand, but we're not taking that into consideration here. We're just following the happy path. And the happy path is a tuple with an OK atom as the first element, and then the data structure as the second element, which we assign to the empty variable list. And then finally, we return that variable from the function. So now when we call soccer team.list all, we can see the list of players that we got from our API, right? Cool, 1 out of 2. Now what we want to do is we want to find the goalkeeper and return the map, right? We're going to return a map with the name of the goalkeeper and then the position goalkeeper, right? So we want to be able to find one element from that list of elements. Cool. So this is the method that we're going to implement now, get goalie. And we're going to call it soccerteam.getGoalie. Again, most of it looks similar to the list of players, looks exactly the same. We have the endpoint as a string, assign it to the URL variable, use the getURL function from the HTTP library, then pipe that to the parse function, which looks exactly like the parse function before. Except that now we're going to pipe all the players that we have into another function called findGoalie. So findGoalie, remember the pipe operator. The pipe operator redirects the return value from the previous function as the first argument to the next function, which in this case is findGoalie. So let's look at what findGoalie looks like. FindGoalie looks like this, 3 clauses. On the first clause, it tries to match the first part of the list, which is the head, the first element of the list, to a map that contains the position equal to goalkeeper. If that sounds complicated to you, that's as complicated as it's going to get, because that's it. Like we solved, like this is, the terminating scenario. If this happens, we found our goalie. Like looking at this code and trying to understand, it will not get more complicated than the line that you just read. That's it. There's no if statements, no for loops, that's it. So once that match happens, all we care about is returning that head element. We don't care about the rest of the list. That's why we're using the underscore character here, because that can be whatever it wants. That's the Elixir way of explicitly ignoring something, is using underscore. We don't care about it. If the first element of the list that this function just received is a goalkeeper, that's it. That's all we want, right? However, if it's not, then that function won't be a match. And Elixir is going to try to look for the other clauses of that same function. So the next clause is, well, since the first element is not a goalkeeper, I don't care what it is. So it's, again, it's going to ignore the first element. What it cares about is the remaining of the list, right? Well, if the first element wasn't a goalkeeper, then the goalkeeper is probably part of the rest of the list. So I'm going to grab the rest of the list, assign it to tail, and call the function again. That's the recursive scenario. So assuming that the goalkeeper is part of the tail, we're going to keep going back between the first and second clauses until there's a match, right? We're assuming there is a match, because if there isn't, then the last time that the second clause is matched, then tail is going to be an empty list, because we're going to have gone through all the elements of the team and we won't have found a goalie. And for this particular scenario, I'm considering that an error. So I'm matching on the last clause and explicitly raising an error. So the last clause will only be matched if we ever give it an empty list, right? And like, for those of you that know like the basic rules of soccer, like, the team has to have a goalie, right? Even if the goalie receives a red card, they're gonna grab the worst player of the team and make him a goalie. Like, there cannot be a soccer game without at least 2 goalies, right? So again, notice there's no for loop and then there's no while statement. We're able to write the simple, very realistic actually program using all the 3 pillars of functional programming: stateless functions, recursion, and pattern matching, which it gave us a program that's, like, I think it's easier to understand, easier to test, and easier to distribute than its object-oriented or procedural counterpart, right? And again, remember, like, once you get through that first clause barrier, like, you look at the code, you're kind of like, wait, this is weird. I've never seen something like that. But once you start breaking it down, again, that's as complicated as it gets. Everything else is just a simpler clause, and it's just easier to understand, right? Now let's go back real quick to that first example, factorial. Now, like, if y'all understood the previous slide, this one should be like a breeze. Like, all right, I get this, right? So just 2 clauses, right? The terminating scenario and then the recursive scenario. Now, there's an issue with this code. So this code works, right? It's not the best it could be, but it works. But here's an issue. If you call this code with a huge number, like 10 million, then something bad is going to happen, right? If we look at the activity monitor, so we're going to see that the beam, the virtual machine, is going to devour our memory. So 5 gigs of memory just for running that factorial, right? Now, there's one thing we can do to make this code better and play well and leverage the Erlang virtual machine, which is implementing tail call optimization, right? Other languages, I believe, offer this optimization as well, which allows you basically to write recursive functions in a way that the compiler reutilizes entries to the stack. It doesn't have to keep adding entries to the stack every time it calls the functions again. Like, once it realizes it's going to be calling that function over and over, it stops adding entries to the stack and just reutilizes that. So what that means is that it's going to consume a lot less memory. Now, the way to achieve that in Elixir is to make sure that the last expression on the recursive scenario is a call to the function itself. So remember, the last expression on the recursive scenario must be a call to itself. Now let's look back at that example. So what is the recursive scenario here? The first or the second clause? Cool. Now remember, for tail call optimization, the last expression on the recursive scenario must be a call to the function itself. Now, what is the last expression on the recursive scenario here?
N times factorial.
Exactly. So that's the issue. It's not factorial, it's n times factorial. So that small detail prevents the virtual machine from using tail call optimization. And that's why running this code with a huge number is going to cause that memory issue. Now, we can rewrite this code to use tail call optimization like this. Now notice the entry point, the public API to this module is still the factorial function. We're still giving it one argument. But then inside this function, we're calling a function that has an accumulator, right? So it's going to match that first call, and then it's going to go back between the first match, which won't be a match until the terminating scenario, and the second one. So the second version is the actual recursive scenario, but in this case, it is literally calling itself. That is the last expression of this function, is a call to the function itself, right? So we run this code again, and then we can see a huge difference, right? Less than a gig, like 24 minutes, right? So that's like the small detail that can make a difference in your program when you understand how to leverage, not only how to think functionally, but how to leverage the technology in question, which is, to some extent, is Elixir, but it's also Erlang, the virtual machine, that has been deployed for over 30 decades and battle tested, and it's pretty solid. So that was it for today. Covered quite a lot of stuff, and thank you. I don't know if there's any questions or. Questions?
Yeah, I've got one. Are you using this in production?
Yeah.
Yeah?
Yeah.
For web apps, it sounds like.
For web apps, using Phoenix, yes. So a couple of like big companies that have been using this to some extent. There's a messaging app, WhatsApp.
Yeah.
So they they have been using Erlang. So they've been using Beam, the virtual machine, for quite a lot of time. And when you look at like the numbers and the resources that they use, it's ridiculous. It's like a handful of servers for like billions of people using it in the world. And there's various cases of people being able to reduce, like drastically reduce the amount of machinery that they use to serve websites.
What type of other systems are typically coupled with it? Or are there message queues or databases or NoSQL or?
Yeah, so CouchDB is one of them. Again, it's not Elixir. So Elixir is a rather recent language. It's only been around for less than a decade, like 8 years since its like beta release, right? But like everything that we say about like the underlying technology applies to Erlang. So Erlang was the language used for like CouchDB, and I think, is it called Ryak? R-I-A-K? Ryak.
I haven't heard of them.
Yeah. So they use Erlang as well. Yeah. So.
You can go first.
Oh, good. Yeah,
Oh, so I was just curious, new to the whole functional programming paradigm. What does architecture kind of look like for dependency injection, or I just don't have a concept in my mind of what architecture looks like in a functional paradigm.
That's a really good question. So specifically dependency injection, I personally don't recall seeing it in Elixir. So the one industry, the one community that dependency injection is really heavily used is Java, right? Other than Java, in C#, Java languages, C#.net. Other than that, when you start venturing into other paradigms, my guess is that a lot of the problems that dependency injection solve, you don't run into them, right? So dependency injection is a solution for problems that you probably won't be finding in other paradigms.
So that Can you go back to your slide where you had like the okay, you're doing the pattern matching of like the okay and the error?
Yes.
Did I just make you break your computer?
Yeah, it seems like dependency injection is based on object-oriented thinking, right? You're
Yeah.
injecting some
Yeah.
more complicated thing.
Yeah, how do you kind of handle, like, you know, then even aside from dependency injection, like really in version control, like when you have business logic that you don't want to, you know,
Yeah.
be involved in the details, do you use like, I mean, I'm new to functional programming, but I know there's like a concept of like higher order functions.
Yeah.
Do you do that to like encapsulate
100%.
some of your dependencies so that,
Yes.
okay.
Yeah, so that's exactly that. Like, dude, you hit it on the spot. Higher order functions help you a lot with that because you can literally just pass the business logic as a function, right, as an argument to another function, right? And then if you want to test that, you can just pass a mock version of that function, you know, and then you can just like, yeah, you can separate your business logic from, you know, the presentation portion, from the, you know, data management portion. Like I would say that it's a lot easier to reach the separation of concerns using a functional language than it is using an object-oriented language. Mostly because of, you know, pure functions, right? You're not initializing an object and then calling a method that needs to look into the object for the properties, right? You're literally calling functions that they should have all the data they need as the argument, right? So
Yeah.
So if you really want to go down the rabbit hole, look up higher kinded types, because this will give you what he's talking about, where you can kind of substitute that inversion of control thing, but it'll be type safe. Yeah, you'll come back to me in like 6 months, and you'll be like, why did you do this to me?
So one thing that really struck me about this is, from the outside, it kind of looks like the same way that a parse file would work. Correct, stop me if I'm wrong here. But it works the same way with an object-oriented language, where I'm just doing a parse file on some value. But inside, what's actually happening is instead of having like constructing an object that has the OK state and the error state and spitting out a result, I'm just matching, I'm passing in that, and then pattern matching is just kind of taking care of
yeah,
whatever it is. Instead of needing to construct separate objects to get them polymorphism,
right.
pattern matching is actually going to do that.
Yeah, and you know, coming from like Java, like at first this might be like, oh, this is method overloading, right? Well, except that like method overloading is with types only,
Yeah.
right? You can define different versions of the same method. They take in different types, right? This is like taking a step further, right? You can actually do something similar. I haven't like shown the syntax or anything, but you can do something similar when you check for the type, right? It's called a guard clause in Elixir. But like, yeah, pattern matching is freaking dope.
So you mentioned that you use Elixir for web apps, but beyond web apps, what kind of problems does Elixir make the most sense to solve?
That's a really good question. And then the answer to that problem is not the language necessarily, but the underlying technology, right? So the language is just like the very, you know, top of the pyramid, so to speak. The language just happens to be nice, right? It just happens to be to almost read like Ruby, right? And that's intentional because the guy that created it came from years of Ruby, you know, a contributor to the Rails framework, to the Ruby language to some extent, and he was looking for a language that looked like Ruby, but didn't run into the same problems as far as concurrency, right? Ruby, kind of like Python, they run into a roadblock when it comes to concurrency, which is the GILP, the global interpreter lock, right? And it's part of the language. Like it's been there since the beginning, and it's super hard, not to say impossible, to just remove that out of the equation and then all of a sudden make the language distributed, right? And then Joseph Aline, which is the creator of Elixir, he was looking around for solutions until he came across the Erlang virtual machine, which had all the items on his checklist for the language, for a platform that he was looking for, except Erlang is gross. Like if you look at the language, it is extremely hard to digest, right? So what he did, he basically created a language, another language, Elixir, that looks like Ruby, which is super easy to understand, but compiles to the Erlang bytecode, right? So now going back to answering your question, what kind of problems does it solve? Like the platform itself, Erlang, the virtual machine, it offers a set of built-in tools for writing concurrent and distributed code, right? Which, because the nature of the language itself, both Elixir and Erlang, they rely heavily on these three pillars: pure functions, pattern matching, and recursion. It's very easy for a language implementer, for like the virtual machine, to read code like this and make it distributed, right? So as I was mentioning, you know, like it's more efficient, it's more memory efficient, and you can handle a lot more load with a lot less machinery when you do something like that. So anything that's like network heavy, when you're getting like a bunch of like requests and you need to process that and spin it off to multiple servers, asynchronous calls, all of that stuff, Erlang is, you know, a great platform for writing code like that.
So kind of in line with that, what does async programming look like in Elixir?
That's a really good question. It's not part of the talk, but like I can like browse and show some of that code.
Yeah, because I mean, just being familiar with, you know, JavaScript's one end to Go, kind of has Go routines, which is very different to Java, which is, you know, kind of hard to get that reactive.
Yep.
You know, it's not very natural in the language. So I was just curious what it looked like.
So Elixir has this thing called GenServer. So that's essentially, so again, because of the set of tools that are shipped with the virtual machine, the Erlang virtual machine, it's called OTP, Online Telecommunications Platform, which was initially developed for telephone lines. You know, computer networks are very similar, so it just happens to work. So they have this module, part of OTP, called generic server, right? So that's how asynchronous communications, so that's how you can write asynchronous code in Elixir. One way you can write asynchronous code in Elixir and Erlang is using a generic server, right? Which the implementation of the server is a bunch of callbacks, right? And then once you have a client, so you don't have your client communicating directly with that code, right? You have a client communicating with the virtual machine, and then the virtual machine is making all of those callback calls, right, on your behalf, right? So in the same way that when you write a callback in Node.js, you're not, like, your code is not calling the callback, you're giving it to V8 to call it, right? So this is kind of like the same thing in Elixir, but you don't use callbacks, like, you know, function callbacks the JavaScript way, right? You write kind of like a, you know, I think delegator in iOS, you just like state the functions as part of your module, and then you mix in the GenServer module, and then you let the virtual machine call those methods for you. So that's like essentially like that's how asynchronous code works in Elixir, right? In Erlang. So, and somewhere here, I don't think it's here, but like when we look at more advanced, right, process ID. So this right here, process ID. So this process is not operating system process, not OS process. It's a concept of process that's specific to Erlang. And a process is a lightweight concept. It's not as heavyweight as a process is in an operating system. And a process can live across the network, right? So calling GenServer call PID, this process can be either part, like you don't know, this part is transparent to this code, whether this process is in the computer that's calling it, or if it's in another computer in the network, or if it's on the other side of the world, right? So that's what's cool about the virtual machine, is that it makes like all this code like just magically work once you adhere to the style of programming, right? So again, pure functions, recursion, pattern matching. Like if you follow like the recipe, then once you want to distribute your servers, you kind of like just turn on different servers. You just like connect the nodes between themselves, and the distribution is taken care of by the virtual machine. And this is like an advanced topic for me. Like I personally have not worked heavily with this, but like I know that this is like the entry point for distributed code.
Do you know of any?
No, go for it.
Do you know of any good GitHub repos you can look at?
Like not off the top of my head, but like Phoenix, which is the framework itself for like the web framework, is a good one. I know there's like the awesome something pattern that like a lot of people use on GitHub, like awesome Elixir, awesome Ruby, and then if you just look for like awesome Elixir, I'm pretty sure there's like a GitHub repo with a bunch of open source. Or you can also go to GitHub and go to like popular repos and just filter by language, and Elixir is there, and then you can just like browse. That's a great question. That's the best way to learn like a new language or framework, is to just browse through the source code. So yeah, really good question. So.
Okay, so this is super badass. Now I'm excited again. I talked
Awesome.
to you earlier right there. So for external libraries, like the support and stuff like that, because I'm dealing with external things that are not written in Elixir or on the Erlang JVM, VM. But I'm dealing with Java and the JVM, stuff like that. But sockets will work just fine, things like that. So what kind of libraries that do have side effects and so on, like the external stuff, what kind of support does Elixir have for that?
So there's like a the ecosystem, Hex package manager. You can add external libraries, but what's cool about that is another feature of, again, not the language but the platform. Once you start reading about it, you're going to see this a lot. It's called fault tolerant, right? And they follow a concept of the let it crash, right? And what that means essentially is that, remember the process I told you? There's like hundreds and thousands and millions of them. And when you run Elixir applications, and a few of these processes are called supervisors. And the goal of the supervisor process is to monitor children processes. And if they die, there's a bunch of different ways that it can treat that specific situation, right? So even when you're using an external library, when you add it to an Elixir project, it's going to be part of the supervisor tree, right? So when you're writing a code that crashes on one particular scenario or one particular area of your application, your entire application is not going to crash, right? Only that particular case, and then the supervisor will then take care of it, right? And then there's default behaviors for supervisors, but you can also write your own supervisors depending on your needs for your application, right? So some of them you want to start right away. Some of them you might want to do some cleanup before starting. Some of them you might just want to let it die and not resuscitate again. So there's 3 or 4 default behaviors, and then you can also like write your custom ones. So that's kind of like how it works with external dependencies. So everything is a process and everything is managed, and that's why like you're gonna see like the let it crash and the fault tolerant aspect of Elixir, because like it's part of the language to try and make each part not affect the whole.
What about data durability? So I got like 5 of these processes running, and 4 of them are okay, and I get a bad piece of data. It comes in, it crashes on it, but I don't necessarily want to lose the data that I read there. I not necessarily want to give it to somebody else because they'll probably crash too. But what happens in that case? Where you kind of
again, it depends. So each process you can also code what it needs to do when it crashes.
Oh, okay. Right.
So if I remember correctly, like you can implement some kind of flush. Right, so even when it crashes, there's like a function that's going to call before it actually crashes. So there's different things you can do about, keeping the data around. And there's also it's called ETS tables, which is again, it's part of the virtual machine. It's part of OTP. It's part of Erlang, which is kind of like a built-in type Redis. So it's part of the language. So it's pretty powerful. Once you start reading about it, you're like, holy shit, like 30 years ago, people were solving problems like this. So, yeah.
Nice, thank you.
Yeah.
So, the functional language that I'm most familiar with is Haskell. In Haskell, you literally can't have side effects. Like, the language prevents it. And I know, just from reading it, that's not what's happening here. But is there an opt-in where you can say, like, so essentially with Haskell, if it's not marked with a certain type, it's impossible to have a side effect. So now, as a consumer of a function, not only do I just kind of hope that the person who wrote the function was following these rules of not having side effects and all of these things, but I'm guaranteed it by the language. Do you know if there's any sort of opt-in guarantees like that for Elixir?
I don't know.
Okay.
I don't know.
Yeah.
My first guess would be that the language is not as strict about that as other languages like Haskell.
Yeah.
But I don't know.
Okay. Cool. Any last questions? All right. Round of applause.
All right, everybody. That will pretty much do it for this evening. If you don't mind helping me set up the room before we all get out of here, I would very much appreciate that. I also would not be doing my job because we at Power EMS are actually hiring, and I forgot to mention that at the start. So if you are interested in doing software development at Power EMS, please come talk to me. Maybe we can see if it might be a fit. Still looking for speakers, so if you are inspired to give a talk based on something you saw tonight or something you're doing, please come find me. And I think that's it. Any other announcements? All right, get out of here. Or don't get out of here, help me, and then get out of here.